All right, numbers combine through the operations of addition, subtraction, multiplication, and division to produce other numbers. Sometimes how they combine is dictated by convention. Like with the order of operations, other times the properties about numbers exist simply due to how those operations work. So we're going to add the following numbers without using a calculator. Although order of operations tells us we should add from left to right, think about an easier way to sum these numbers, show how you sum them. So I want you to pause now, do it on your own, and then go ahead and press play when you're ready. So what I'm going to do is I'm going to look at all of the numbers that easily add up to 10. So 9 and 1 makes 10, plus 3 and 7 makes 10, plus 4 and 6 makes 10, plus 2 and 8 makes 10. So it's 10, 20, 30, 40 total. So what I did is I rearranged them in my head. You could have rearranged them how you would like to, put 9 plus 1 plus 3 plus 7 plus 4 plus 6 plus, and so on. So addition and multiplication have two very important properties with very technical names. The next exercise will review these properties. The commutative property, so we're going to fill in the missing blanks for each property. 8 plus 4 gives the same sum as 4 plus 8. Both sums equal 12. Commutative property of multiplication. 6 times 3 gives the same product as 3 times 6. Both products equal 18. The associative property of addition. The sum parenthesis 3 plus 5 plus 9 gives the same result as the sum 3 plus parenthesis 5 plus 9. Both sums are equal to 17. The associative property of multiplication, the product 2 times 5 times 7, gives the same product as 2 times 5 times 7. Both products are equal to 70. The commutative property and associative property essentially give us permission to rewrite addition and multiplication problems in different orders than what they are normally given. So give an example that shows that subtraction is not commutative. If you can't think of one on your own, one would be that 3 minus 7 is not the same as 7 minus 3. You will notice that in the first one, 3 minus 7 is negative 4, and 7 minus 3 is 4, so those are not equal. Even though subtraction is not commutative, we should remember a very important fact about subtraction. It can always be made into the addition of opposites. So change the following expression involving addition and subtraction into one only involving addition, and then use the commutative and associative properties to quickly determine the value of this expression. Through this, please review some properties of negative numbers. So 7 minus 3 can be the same as plus negative 3, plus 8, and instead of 8 minus 2, it's plus negative 2. And instead of minus 6, it's plus negative 6, plus 1, and then remember a double negative makes a positive 3. So now we can go through and find what? So we're going to look at, we're going to change things around a bit. So I have positive 7 and positive 3 is 10. And then I have a few other ones that we can switch around and see the best way to deal with them. So I have a negative 2 and a negative 6. So negative 2 plus negative 6 is negative 8. And then I have a positive 8, and those cancel each other out. So that would be 0. You don't have to write 0, but I will just for the sake of this. Then I have a negative 3 and a positive 1. If you combine those, they are negative 2. So now what we have left is 10 plus 0, which is 10, plus negative 2, which is 8. We should be able to now extend the commutative and associative properties for numbers we know to numbers we don't know. So variables. One of the very nice ways to illustrate the usefulness of these properties is in combining two or more expressions. So 5x plus 2x, they have the same like terms, so they become 7x. 7x plus negative 3x, they're the same terms, so they are 4x. And negative 8x plus negative 2x is negative 10x. In the following exercise, we show how two linear expressions are combined using various properties. List what the properties are. So for the first one, 3x plus 7 plus 2x plus 8 equals 3x plus 7 plus 2x plus 8. This is the associative property of, so associative property of addition, because it changes the grouping. Then we have 3x plus 7 plus 2x plus 8 equals 3x plus 2x plus 7 plus 8. You'll notice that they rearranged, that the two with x's are now next to each other. So this is the commutative property of addition. So commutative property of addition. And finally, 3x plus 2x plus 7 plus 8 equals 3x plus 2x plus 7 plus 8 in parentheses. So again, we change the grouping. So it is, again, associative property of addition. And the last piece of this, the 5x plus 15, this is nothing. It just combined like terms. It showed that the 3x plus 2x became 5x and the 7 plus 8 became 15. So combine the expression below. Replace subtraction by addition of opposites if needed. So we're going to, I'm just going to end up moving everything together. We're going to do some commutative property. So 4x plus negative 2x plus 6 plus negative 9. Now, if you look at it, we have everything together that are like terms. So 4x minus 2x, or 4x plus negative 2x, is 2x. And 6 plus negative 9 is negative 3. The next one, negative 6x plus 10x plus 9 plus 3. So negative 6x plus 10x, if you look at that, it becomes 4x, and 9 plus 3 is 12. And our last one, 4y plus negative 7y plus negative 10 plus negative 3. The reason why we do plus negative is because sometimes it's hard to see that negative 10 minus 3 is actually two negative numbers. So now when you make them plus negatives, you know to combine them to make a larger negative. Negative 10 and negative 3 combine to make negative 13. And then 4y plus negative 7 is negative 3y.